See, now we will discuss some problems, okay, that is related to the rate constant of 0 order, first order as well as the half life. Okay. So, this is a problem here that is given rate constant of first order reaction is 5.5 into 10 to the power of minus 14 second inverse. Okay. Here the rate constant is given. Find the half life of the reaction. So, you are supposed to find the half life of reaction. So, how to find the half life? See, as you can see here, it is a first order reaction and then it is given to find the half life. So, it is very simple. As I told you, if you know half life of first order reaction, you can find what is the value of K. If you know K, you can find the half life, okay, vice versa. Now, we will apply the formula. So, what is the formula? T half, it is T half is equal to 0.693 by K. This is the formula. So, now we will see what is given. Rate constant is given. Rate constant of the first order reaction is given. So, we will directly substitute that 0.693 divided by, it is given as 5.5 into 10 to the power of minus 14. Okay. Now, if you work it out, the answer comes out to be 0.126 into 10 to the power of 14. So, be very careful while writing the unit here. See, here it is given in second inverse. Make sure you also write it in second S. Okay. So, it is very simple problem, easy problem, and many times they have asked this in the exam. Okay. Now, if you are asked to find in minutes, so it is very simple, just divide it by 60, you will get answer in minute. Okay. So, let us go to the second problem. So, what is given here is time required to decompose SO2Cl2 to half of its initial amount is 60 minutes, half of its initial amount. So, from this what you can infer, T half is 60 minutes, okay, T half is given as 60 minutes. If the decomposition is first order reaction, decomposition is a first order reaction, calculate the rate constant. Again, which formula you have to use? The same formula, that is T half is equal to 0.693 divided by K. So, in this case, what is given? T half is given. So, from this you can see half of its initial amount. So, T half is given as how much? 60 minutes. T half is given as 60 minutes. Okay, but here what I will do is I will be converting it into seconds. Why? Because as you know, unit of rate constant K, okay, for the first order reaction, it is second inverse. So, I will be converting this minutes into seconds. Okay. So, how to convert it? 60 into 60 seconds. Okay. So, now the same thing I will be substituting here. Here you have to find what is K. K is equal to 0.693 divided by 60 into 60. So, answer we will be getting is 1.925 into 10 to the power of minus 4. And what is the unit? So, here it was given in minutes, we converted it into seconds. Now, unit is second inverse. Hope you understood this. See, the problem given here is like this. The first order reaction has rate constant this much, 1.15 into 10 to the power of minus 3 second inverse. How long will 5 gram of this reactant take to reduce to 3 gram? Okay, so this is the question that is given. So, here since it is mentioned it is first order reaction. Okay. So, you have to use the equation for rate constant of the first order reaction. So, what is that? We will write K is equal to 2.303 divided by T log of R naught by R. Okay. Now, what you have to find here, that will I will tell you how long. So, what does this tell you is how long means nothing but time. Okay, you have to find now what is the time. So, we will see what is the data that is given, we will write it down and later we will find it out. So, what about K, is it given? K first order reaction as rate constant. So, from that you can get K 1.15 into 10 to the power of minus 3 second, and that's fine. Then this T is not given, we are supposed to find T. T I do not know, it is a question mark. Then what about R naught? That is the initial concentration of the reactant. Okay, how long will 5 gram? Okay, so 5 gram will refer to the initial concentration. Reactant take to reduce to 3 gram. Okay, so initially it was this and now it has become 3 gram. So, what I will write? R is equal to 3 gram. So, we are done with the given data. So, now we will substitute it in this particular equation. So, what becomes? K is equal to, so I have to find T, take it to the other side, that is 2.303 divided by, what is K here? K is 1.15 into 10 to the power of minus 3. Then what else is given? Log R naught. What is R naught? It is 5. And what is log R? It is 3. So, here you have to find the log. Okay. So, we will do that. See, first we will see what is log 5 by 3. You can do it in many ways. Okay. So, when you do the simplification, you will get it as 1.6666. So, it is always better to take 4 digits after the decimal point. So, now what you have to do is you have to find what is log of 1.666. Okay. So, now while finding the log, you have two parts. Okay. One is the characteristic part, other is the mantissa part. So, characteristic part you can write it easily even without looking at the log table. Okay. So, it is very simple. See, here you have only one digit before the point. So, it will be like 0 point. So, suppose if it was like log 200.1, just an example. So, how will you write the characteristic? You have 3 digits here. So, when you have 3 digits minus 1, it will be 2 point. So, that is the characteristic. So, that was just an example to let you know. Okay, now about the mantissa part. How to write the mantissa part? See, for that you will have to use the log table. So, you know, in a log, if you look at the log table, it will be having mainly 3 parts. First, you will be having a main column. You will be having a main column like this. Here you will be having a main column. Then you will be having a difference column, and then you will be having a mean difference column here. Okay. So, what you have to do now is for the first 2 digits, look in the main column. Okay. So, just write it here 16. Okay, 16. Then in the difference column, look for the third digit, that is 6. 6. So, just see where those two intersect and take that reading. Okay. So, if you refer the log table, it comes out to be 6 is 2201. Okay. And we have a 4th digit here. So, for the 4th digit you have to look into the column of mean difference. Okay. That you have to add it here. So, the mean difference value comes out to be 16. So, you just have to add it, it becomes 2217. Hope you understood this. For the Mantissa part, what you have to do? You have to look at the log table. So, how you will be finding the log? For the first, so in the log table, you have 3 parts. One is main column, difference column and the mean difference column. Okay. Take the first 2 digits. Okay, do not worry about the point and all. First 2 digits, look into the main column. Okay. And for the third digit, look into the difference column, see where both intersect, that value comes out to be 2201. Okay. Then you have 4th digit. Okay. For that you have to look it in the mean difference column, 16, and you have to add it. So, you get it like this, 0.2217. This is the log. So, I will substitute it here, 2.303 divided by 1.15 into 10 to the power of minus 3 into 0.2217. You can work this out. Answer will come out to be 0.4439 into 10 to the power of 3 seconds. That is equal to 443.9 seconds. So, this is the answer. So, you can just work it out simply, you can get it very easily. Okay. So, hope you understood this. So, we will go to the next problem. See here what is given. Calculate time in seconds for decomposition of nitrogen pentoxide, which follows first order kinetics when the concentration of N2O5 drops from 0.1 molar to 0.01 molar, K is given. So, it is again a very simple problem. So, you can easily solve this. So, as I told you, here it follows first order kinetics. So, obviously you have to write the equation for the rate constant of first order reaction. K is equal to 2.303 divided by T log of R naught divided by R. Okay. So, this is the formula which you have to use. Okay. Now, let us see what is given. So, you have to find time in seconds. Okay. So, we will see what is given now. So, time I do not know, then K is it given? K is rightly given here, 6.22 into 10 to the power of minus 4 second inverse. Then what about R naught? R naught. See here, we will read the question again. Concentration of N2O5 drops from 0.1. It drops from 0.1 to this value. That means this is the initial concentration. So, R naught I will take it as 0.1 molar. Okay. And what about R? R is equal to this one, it is 0.01 molar. Okay. So, with this in mind, we will substitute it in this given formula, that is K. So, we have to find T. So, I will write T is equal to 2.303. I will substitute for K, it is 6.22 into 10 to the power of minus 4. Then log, you have to take log of which one? R naught. What is R naught? 0.1. R is 0.01. So, what is this? Okay, if you simplify, it is quite simple, comes out to be log 0.1 divided by 0.1 is nothing but log 10. So, as I told you, 10, log 10, you must all be familiar with that, that is log 10 is nothing but 1. So, directly I will substitute it here, 2.303 divided by 6.22 into 10 to the power of minus 4 into 1. So, if you can easily simplify this, answer comes out to be 0.3702 into 10 to the power 4. See, what is the unit here? From this we will be writing this. See, K is given in second inverse. So, what should be the unit of T? It should be second. So, this completes the problem. See here, we will go to the next problem. 60% of first order reaction was completed in 60 minutes. Okay, when was it half completed? Okay, so we are going to the next level of the problem. So here what you have to find is when was it half completed. That means that is obvious that you have to find what is T half. Okay, to find T half, what you need? For the first order reaction, what you need? You need K, right? To find T half, you need K. So we know the relation between the two. Okay, but is the K given in this equation, in this question? No. So first what we will do is we will find what is K and then we will substitute the value of K and find the half life. Hope you got this. Okay. So you are asked to find half life here, when was it half completed. Okay. So but K is not given here. So first we will be finding K from the data given. Later we will substitute for K and then we will find what is T half. Okay, so we will solve the problem, we will start solving the problem. First what we will do is, again we will write the equation for the rate constant of first order reaction, that is K is equal to 2.303 divided by T log of R naught by R. Okay, so see here we are finding K now. Okay, this is the first part. So what is T here? T is given as 60 minutes. Okay, let it be as such. Okay, now then what is R naught here? R naught is the initial concentration of the reactant. Okay, 60%, it is given in 60%. Okay, so whenever you have such cases, you have to take R naught as 100. Okay. Now, what is R then? See, 60% is complete. Okay, what is remaining now? That is after 60 minutes, it is 100 minus 60, that is 40. Is the concentration of the reactant. Okay, so 100 is the initial concentration, this is the concentration after 60 minutes. Okay, now we will be substituting it here. K is equal to 2.303 divided by 60 into log of what it is, 100 divided by 40. So how you will find the log of this? Again log of 100 by 40. So for that this and this will get cancelled. So that is nothing but log of 10 by 4. So 10 by 4 is 2.5. So you have to find what is log of 2.5. So how to find the log? See here, before the decimal point you have only one digit. Okay, so what is the characteristic? As I told you earlier, it is 0 point. So after that what you have to do to write the mantissa part? You have to look into the log table. So here you have only 2 digits. Okay, that is 2 and 5, 25. So look for 25 in the main column and you do not have any third digit. So just look into what is the value of 25 and 0. Okay, so it comes out to be 0.3979. So log 2.5 is 0.3979. So I will be substituting it here, 2.303 divided by 60 into 0.3979. So you can simplify this. Okay, answer comes out to be 1.527 into 10 to the power of minus 2 minutes. See, I am taking here minutes, so it is given in minutes. Okay, so what is the unit? Right, inverse. Okay, so this is the value of, it comes out to be this much. Okay, so this is the value of K. So now we are done with the value of K. So what you have to do now? To go to the next part. When was it half completed? Okay, so now we will write the relation between half life and K for the first order reaction. It is 0.693 by K. So let's substitute it. 0.693 divided by, what is the K value? It is 1.527 into 10 to the power of minus 2. Be careful, it is given in minutes, I am writing it in minutes. So if you simplify this, you can just simplify this, answer will come out to be 45.38 minutes. So this is the final answer. Okay, we have found what is T half for this reaction. See here, the next problem is to show that in a first order reaction, time required for the completion of 75% of the reaction is twice that of the half life of reaction. So we can write this, we can write it as like this. So T 75% is equal to 2 into T half. So you have to show this. Since it is a first order reaction, what we can do is we can start with the first order rate constant, that is K is equal to 2.303 divided by T log of R naught by R. Okay. So now we will write separately what is T 75 and what is T half. T half is also nothing but 2 into T 50%. Okay. So I will be writing now. So I will take T to the other side. T 75% is equal to 2.303 divided by K log of R naught is the initial concentration and R is the concentration at time T. Okay, now what is R naught for T 75? R naught for T 75, R naught is 100 and what is R? R is equal to 100 minus 75% of the reaction is complete. So it is 100 minus 75, that is nothing but 25. So log of 100 divided by 25, it is nothing but T 75% is equal to 2.303 divided by K log 4. Okay, let me take this as 1. Okay, now let me write what is T 50% or T half, that is equal to, so let it according to this, that is 2.303 divided by K log of, so what is the initial concentration? R naught is 100 and R is 100 minus 50, that is 50. So that is T 50% is equal to 2.303 divided by K log 2. With this I will take it as equation 2. So when you do 1 by 2, so it will give you T 75% divided by T 25% is equal to, when you take the ratios, it will be like this, 2.303 divided by K log 4, it is 2.303 divided by K log 2. So this and this will get cancelled. So we will be left with log 4 by log 2. So log 4 is, so characteristic is 0.6021 and what is log 2? Log 2 is 0.3010. So when you simplify this, it will come out to be 2.0003. So which we can take it approximately as equal to 2. So therefore, what you can show is, T 75% is equal to twice of T 50%. Okay, so see, when it comes to the first order reactions, okay, it becomes very important to know about this relations. Okay, what is the relation between half life and 75% half life and the other ratios. So I will tell you one easy method to remember that. Okay, so you can use it while solving the problems. See here, we will start with initial 100. So for it to get reduced to 50, time required is T half. Okay, again for it to get reduced to 25, what is the time required? It is again T half. Again for it to get reduced to half of it, that is 12.5, time required is T half. Again you can just write it, T half, what is it? It is 6.25. Okay, again you can just go on writing T half 3.125. So you can just continue it like that. Okay, so how can easily remember? See here, from here to here, how much of the reaction is complete? 50% is complete. So it is T half. Okay, so when you go from here to here, 1 T half, okay, this is 1 T half, that is not needed. However, see here, when you go from 100 to 25, how much is complete? 75% of the reaction is complete. Okay, that means it is T75, that is equal to how many T halves? You have 2 here, so it is 2 T half. Okay, so when you go from 100 to 12.5, so how much it is? 75, then it is 87.5% is complete. So time required for 87.5% completion of the reaction, that is equal to how many T halves? 1, 2 and 3, 3 T half. Okay, next you go for the next one. Here, see here, how much will be complete reaction from 100 to this? How much will be remaining? 93.75%. Okay, so how many T halves? 1, 2, 3 and 4 T halves. So 4 T half is equal to T 93.75%. Okay, so like this you can just go on finding, and finally you come to a conclusion that 10 T half is equal to T 99.9%. So these ratios will be very useful, if you remember it, will be very useful for solving the problems. Okay, whatever I thought earlier, so we will be applying that here directly. So in a first order reaction, for 87.5% decomposition, time required is 90 minutes. Calculate time required for 99.9% decomposition. So here such problems can be easily solved by remembering the relations. Okay, see here how to find this. So whatever I thought earlier, so from that only I will be taking the relation. T 87.5% is equal to 3 T half. Okay, this we have already found. Okay, so now what you can do is, they have given you the time required for 87.5% decomposition. Okay, that is given as 90 minutes. Okay, so T 87.5% is given as 90 minutes. Okay, from this you can find what is T half. Okay, so I will just rearrange this. 3 T half is equal to T 87.5%. So T half is equal to, what is T 87.5%? It is 90 divided by 3. So how much it is? 3 ones are, 3 threes are. So it is 30 minutes. T half is 30 minutes. Okay, so I have just found T half. Once I know T half, okay, I can write what is the relation between T 99.9 and T half. I already know that. Okay, that is T 99.9% is equal to 10 times T half. Okay, that we have derived it earlier. So it is nothing but 10 into, what is T half now? T half is 30. That comes out to be 300 minutes. So if you know the relation between T halves and the percentage completion of the reaction, you can easily solve many problems of this kind.